Hi, everybody. You're probably going to hear my cat screaming in the background again. Can you hear her? Anyway, as we get started today, before you practice doing some graphing of real-world situations, normally we would be doing a reteach. So I'm going to talk a little bit now to you in this video, and then you will get the worksheet with 4 practice. We're actually going to do one of them together, and then you'll have 3 to do on your own. And then you'll watch the next ed puzzle that's just going to add a step on the front of what we're doing today. Okay, so I'm going to present my screen. It just takes me a second, so be patient with me. And we will go out to, okay, so we'll go out to what would look like the Promethean board, and hopefully you're seeing the 4 ways to represent a function. So you already watched the ed puzzle, or should have. So now if we're looking at this, really there are more. There's also, we could have put the mapping diagram in here, but we really, like I said, as we go forward, don't use that much. So now things are coming to us in words. We need an equation which will be given to you today. The next video will talk about how to write that equation, that function rule. We've talked about going from a function rule to a table. Boo on the book that they don't have a negative input on this one. And then we've talked about how to go from a table to a graph. That table is a set of ordered pairs that we plot. So basically there are 4 ways as we head forward that we're going to see our functions. We're going to see them written in words. It's going to be a real world problem. We're then going to write a function rule, call it an equation. We're going to use that equation to make a table of values. Now, when we do use a real world example, we probably won't have those negative inputs because of what that real world is talking about. You don't have negative months, you don't have negative dollars. So, the negatives tend to go away in a lot of our real world examples, and then we're going to graph it. So we're going from words to a rule to a table to a graph. And today, the function rule is basically given to you. Now, before we go forward and do an example together to practice, there were these 2 terms that are new, and one was continuous and the other is discrete. I want you to think of discrete as jumping from one thing to the next, and it usually involves a count, the number of people, your shoe size, or the number of points in a game, or the goals, and things like that. Continuous data, I want you to think as being smooth. It doesn't jump. So you go through all the numbers to go from one thing to the next. So as you're pouring water in a glass, right? So it's a measurement, your weight, even on your scale. If you look at the scale, you might say, oh, well, it jumps from 124 pounds to 125 pounds. But really your weight, as you go from 124 to 125, you go through all the weights in between. It's a smooth thing. So discrete kind of jumps, it's a count, and continuous is smooth, it's a measurement. Now, I talked about that in the ed puzzle, but I thought we could just take a minute. And what I want you to do is I want you to think of each one here, and we're basically, is it a D or a C, discrete or continuous? And I'm going to ask the question. I want you to stop and make your guess, and then I'll tell you which one it is, and we'll just work through this list. I'm going to come over here, and I'm going to be able to draw a circle around it kind of as we go. Okay, so let's start. The first one, number of cars passing a traffic light. Is that discrete data or is that continuous? Make your guess. And did you say discrete? Now, why is it discrete? Because it jumps. It goes 1 car, 2 cars, 3 cars, 4 cars. It doesn't go through all the numbers from 1 to 2 as you go from 1 car to 2 cars. So it jumps. Right. How about the number of students buying lunch each day? Did you say discrete? Same thing. Now, it's not just that, there aren't fractions or decimals. It's the fact that it jumps from one number to the next, okay? How about the amount of water in a swimming pool? And you can think about that as you're either filling it up or even as you were draining it. Would that be discrete or continuous data? Now, this one might kind of help you realize the difference. That's continuous. As you put that hose in the pool and it goes up, it doesn't jump from being 12 inches to like 12 and a half inches instantly. It has to go through all the measurements in between. How about a wrestler's weight during the season? That one would also be continuous. So as you gain weight, you don't jump from 1 pound to the next pound. You have to go through all the partial ones in between. How about the number of points scored in a basketball game? Discrete. You getting better at this, guys? How about the height of a plant growing in a garden? Continuous. It's a measurement. It goes through all the heights to go from one, from when you saw it to the next time you see it. Speed of a race car? Also continuous. How about the number of fish in a tank? Discrete. And finally, how about your scores on a test? Also discrete. Even though Mrs. Woodruff will sometimes give you like an 89.5 or something like that, I don't give you an 89.127. Like there's every possible score isn't there. So hopefully that helped you understand the difference. Basically, discrete graphs, you wouldn't connect with a line, and continuous you would. But you're going to see that I'm going to break what I just said, that rule, because oftentimes the way we set up our graphs, or the fact that we want to make predictions, we need to have the line there to do it, even if it's a discrete graph. But I just want to make sure you understand those two terms going forward. So here were the answers we just got. Okay, so what we're going to do now is we are going to do a practice, and you need today's practice worksheet. So for the people at home, it is on Google Classroom. You can either split your screen and look at it with a piece of paper or print it. You're welcome to pause this video until you have it. The folks in class, you would have been handed a worksheet, and this is actually number 2, because number 2 is a little bit, has everything compared to number 1 is kind of filled in for you. So we're going to do number 2 together. And when we are done, you're going to sign off. You're going to do 1, 3, and 4. And then you will send a spot check to me. And then you're going to watch the next Ed puzzle. And I'll explain that when we get to the end of this, one problem. All right, so let's read it together. LMS yearbooks cost $35 each. The function C equals 35n models the total cost. C is the total cost, and n is the number of yearbooks. Okay, so we defined our variables. They gave us a rule, and they told us that C is going to be the total cost, and n is going to be the number of yearbooks. So if you were to put 1 in, you'd have $35. If you were to put 10 in, it would be $350 total. Okay. We're going to make a table of values, and we're going to make a graph, and we need to show the cost up to, on our graph, at least 150 yearbooks. So you don't want to just put like 1, 2, 3, 4, 5. We've got to get up to at least 150. With real world graphs, lots of times you don't want to just go by ones here. You want to go by reasonable amounts. In yearbooks, we're going to sell not just 5 yearbooks. Okay, so we're going to start by filling out a table. We're going to pick our inputs. We can all pick inputs right now. I'm actually going to put like 6 inputs in here in a second. My first question is, do we use the Fave 5 or the Fave 4? And you should be saying no, because you can't have -1 or -2 yearbooks. So the first number that we would put in, and I do want you to put this number, would be 0. The first realistic input would be, what if we sold none? So I would ask you to start by putting a 0 as your first N. Now we need to put numbers in here, and remember that you've got to have your graph go up to at least 150. So 150 is going to be one of my inputs. So you have a choice now, 0, you could put 10, but you need to get up to 150. So you're going to write now, can you please put in 6 inputs starting with 0, and you got to get up to 150. Go ahead and make those choices right now. So in this chart, 0, 20, 60, you can pick the inputs that you're going to put in, but this one down here needs to be 150. You got to at least get up to 150. So put in some reasonable inputs. You can go by, some 20s or whatever, but get up to 150. Remember, it doesn't matter. Everybody can pick different inputs. Okay, now that you have those inputs, you're going to, oh my gosh, here comes my cat. I never realized, when I'm at school that she's at home screaming, basically. Anyway, she's getting old and a bit senile. So once you have those inputs, you're going to put them in and multiply each one by 35 to get the output. Okay, so that's kind of what we're going to do next. I'm going to go over to my camera and show you mine. You do not have to match mine. However, you do have to have, like I said, from 0 to 150. Okay, I'm going to go over to the camera. Okay, so here was my table. 0 times 35 is 0. I used 20. 20 times 35 is 700. And these were my other inputs. 60 times 35 is 2,100. 35 times 100 is $3,500. If we sell 120 yearbooks, 35 times 120 would be 4,200. And if we sell 150, it would be up to 5,250. Okay, so that's the table I'm going to use, but you definitely should have had the 0, 0, and I told you to make sure you go up to 150. So now when we go to make our graph, we need to, first of all, decide who's X and who's Y, and then we have to make sure that we have a graph that's going to be able to catch this table. Okay, and I'm going to go back over to the board and just show you the piece of graph paper. So this is kind of what you're looking at, right? Now, we're not using the coordinate graph system because there's not going to be negative dollars and negative yearbooks. So we don't need quadrants 2, 3, and 4. So this is just quadrant 1 of the coordinate plane. Now what we need to do is right now put a title on this. So on your paper, put a title. Your book is horrible at this. So what would you call this data? Go ahead and put a title on. How about LMS yearbook sales or something like that, right? That would be perfect. Now we need to put our labels as to what the Y and X axis are going to represent. Now, one of them is going to talk about a cost, and the other one's going to talk about the number of yearbooks. And it does matter which one's which, so we have to think about which one is the independent variable and which one is the dependent. In this particular case, when we go back to the data, what numbers did you put in? You put in for N. That's your independent variable. The number of yearbooks is what you chose. That is your X. That's your independent variable. The cost was waiting for the math to happen. That's your dependent variable. That was your, C. So this is your Y and this is your X. So when we come over here, X is going to be the number of yearbooks, and Y is going to be the total cost in dollars. So we're going to put those labels. So down here, write the number of yearbooks, write the words. And over here, you can even do it sideways or down, put the cost of yearbooks and put a dollar sign. You guys are going to work in a global society where you could be in a company where you're talking to people in China or Japan or Saudi Arabia or England. And so you always need to let people know what your units are for money, because it could be a lot of different ones, basically, from a worldwide basis. Okay, the next thing we need to do is put numbers here. And remember that we need to get up to, how many yearbooks? We want to get up to at least 150. If I go by ones, holy cow, no way. If I go by tens, it's not going to work. How about, would 20 work? Let's see, 20, 40, 60, 80, 100, 120, 140, 160, that works. So how about if we went by 20? So right now, I'm going to be patient while you write 20, 40, 60, 80 by 20s. Write those numbers underneath the little marks here. Now I am going to show you mine in a second. So if you've lost track here. Okay, we're going to go back. We now need to put numbers here. Now we're not going to go by 20s like we did because, oops, I forgot. Let me go back to my camera. I don't have the table there. We've got to go from 0 to up to 5,250 at least on that y-axis. So we've got to find a number that will get us up to, so every block is the same amount and will get us up to at least that, 6,000 even. Okay. So let's go back. Sorry. So now, to get up to 6,000, if you go by hundreds, you're only going to get to 1,000. What about 1,000? 1,000, 2,000, 3,000, 4,000, 5,000, 6,000. That would allow us to get our graph on there. So I'm going to again wait, and you're going to put 1,000, and these represent dollars, 2,000, 3,000, 4,000, 5,000, and 6,000, 7,000, and we're done, right? Okay, and once you fill that in, the next step is to plot the points. The hardest part of doing a real-world graph is what we just did, is setting the scales. You want to make sure that your scales fit the data, and you want to make sure that they're even, and I don't mean 2, 4, 6, 8 even. I mean that each block counts for the same amount going along the x-axis, and then when you pick the scale for the y-axis, so you don't go like 1,000, 3,000, 8,000, 10,000. Every block has to be the same amount. Okay, at this point in time, you're ready to plot the point. 0, 0 is easy. Now on the x-axis, go to 20. And now when you go to do 700, it's a bit of a guesstimate because remember that you have 1,000 there. So 500 would be halfway and then a little bit more. So it's a little past the halfway mark. Then 60 and the 2,100 is a little bit above the 2,000. Go over to 100 or whatever. Your scale might be different, but your point, it might be different, but just go ahead and plot your points. And then let's take a look at the graph. Once you have the points plotted, they should basically fall in a straight line. If they're slightly off, it might be because of the estimating of plotting them, because you're not plotting them in the crosshairs. But plot them, and then we're going to get ready to draw a line. But actually, I just misspoke, and I'll explain that in a second. So plot your points, please. Okay, so let's take a look. And here is what your graph should resemble. Title, label, number of yearbooks, total cost in dollars, 20, 40, 60, 80, 100, 120, 140, 160. I'm going up by thousands. And you'll see the dots for my 6 points. Pretty good in a straight line. Now I put my ruler down or my straight edge and I drew in the line. Now the arrow's out here because we could sell 200 yearbooks. We could sell 210 or 300. And so it is going to keep going this way. However, at this end, there is no arrow because you're not going to sell negative yearbooks and it's not going to cost negative money. So this is actually not a line. It's called a ray. It has one endpoint, but I think you get the gist of kind of what we're doing. So guys, that is our the first example that in your practice. Number 1 is actually easier than that. And then you're going to do 3 and 4. When you are done, you're going to send me a couple answers to a couple questions. That'll be on Classroom. And as soon as you finish that, you're going to watch the next ed puzzle. Well, what is the next ed puzzle going to do? Let me just flip this back around. It's going to talk about what if this rule hadn't been there. So what if it said LMS yearbooks cost $35 each, make a function rule, write a function rule. Okay, so it's going to talk about how to come up with these function rules. That's kind of what we're going to be talking about next, okay? So it's your turn to practice. Thanks for putting up with my screaming cat in the background today. And I'm going to come back to the meeting. And you're now going to finish those other 3, send me the spot check, and start watching that next ed puzzle. Miss you all, and I look forward to seeing you soon. I should stop presenting. Hopefully I'll see you soon. Take care. Keep working hard, guys. I appreciate it, and keep being kind to each other and respectful to Mrs. M. Thank you. We'll see you soon. I'm going to stop recording now.